All right, so hello, I'm back here again. Well, I've been here all day. Sorry, we can only get onto campus so often, so I am recording a bunch of these videos in one day. So excuse me as the day goes on if I am not as well spoken as I was in the beginning of the day. As you can hear, my voice starts to go a little hoarse, but I'm hoping that these will help you out, especially with this lab is for the special senses. This is exercise 14, and the special senses tend to be a more challenging lab. So I'm going to break these videos up into two parts. I'll do the ear, and then I will do the eye. So I'm going to focus in on this awesome ear model here. And for the ear, I'm just going to go straight through the part that you need to know, and we'll talk a little bit about like what constitutes the outer ear, middle ear, and the inner ear. So the outer ear is going to consist of the auricle, which is this part here. Here's your auricle, and this is going to funnel the sound into, take this part off here, the external auditory canal. So here is your external auditory canal. And there are ceruminous glands in here. These are those wax secreting glands that will help to trap dust and particles again so that they're not making it onto the tympanic membrane. And then the tympanic membrane is what you may call your eardrum, but in anatomy we more formally call this the tympanic membrane. So here's the tympanic membrane. It sits right in here. And that tympanic membrane is very important because it's that thin membrane that is going to convert sound waves into these mechanical vibrations, these vibrations in liquid inside the inner ear. So what we're going to do is I'm going to go through now the middle ear. So the tympanic membrane here marks the most inner spot for the outer ear. Now as we move into the middle ear, we're going to talk about the middle ear is going to be in this area here. And we're going to have first the ossicles, the three ossicles. So attached to the tympanic membrane are the three ossicles. And those auditory ossicles are important because they're going to transmit and also amplify the vibrations coming in on the tympanic membrane. So we have three bones. The first one attached to the tympanic membrane here is going to be the malleus, and it looks like a mallet if you look here. So there's malleus. Then there's the incus here, and then the incus, I'm not sure how well you can see that right there, but the incus is then going to attach to the stapes, which is the third bone here. And the stapes is the stirrup. It looks like a stirrup here. So the stapes is just this portion here. They just left it attached here. If you can see that. Well, you can probably see it better if I pull it up so you can see it against my black shirt there. So here's the stapes right here. It looks like a stirrup. And that is the third auditory ossicle. And the stapes is actually going to come into contact with what we call the oval window. The oval window, you can see it a little bit better in your diagram. If you flip to page 151, you'll see the oval window is this little thin membrane where the stapes is going to contact the vestibule. So that makes up the inner ear. So let me go ahead and put this all back here so you can see that. And oops, I might need to put my tympanic membrane back the right way. So now you can see all the parts to the inner ear here, and I'm going to try to tilt that for you all together. Hopefully you get a good view of that. So then, now we're going to go, sorry, that was the middle ear, and now we're going to go into the inner ear. So the inner ear is going to consist of the semicircular canals, the vestibule, and the cochlea. So really quick, we're going to go through each of these parts, and hopefully I can kind of clear up some confusion in terms of the inner ear, which seems to throw most people off. Hearing is a lot more complex than we like to think it is. So the semicircular canals, I'm going to pull this out here. So again, it was just sitting in here. I'm going to pull this out and pull this away for a second so that you can see better probably against my black shirt. These are the semicircular canals. And those semicircular canals are going to be involved with your sense of balance, but specifically with your sense of balance, they're going to be involved with what's called your dynamic equilibrium. So dynamic equilibrium is basically when your head and body are suddenly moving or rotating. Those are the organs that are going to detect that movement and help us to maintain balance while we're moving. So these are the semicircular canals involved with, again, dynamic equilibrium. Now, the vestibule, so the vestibule is going to be this portion here that the semicircular canal is attached to. So I don't know how well you're seeing this here. I hopefully well. But this is going to be the vestibule. All of this is the vestibule here. And the vestibule is going to be associated with static equilibrium. Static equilibrium is your kind of sense of your position of your head, and it allows you to maintain balance and stability and posture when your head and body are not moving. So that's why we call it static equilibrium. And so the vestibule here is going to be responsible for that. And then you can see on the other side, connected to the vestibule, is going to be this snail shell looking structure. It looks kind of like a snail shell. And this is actually the cochlea. And the cochlea is important because it's going to house the sensory receptors for hearing. So it's going to have the hair cells that within the organ of corti that I'm going to take some images. I'm not going to pull that plaque up here, but I'm going to take some images of that for you and do a short video with just the plaque. But here is, you can see the cochlea. And again, it looks, you can open it up and see the cochlear ducts. And it's just going to look like, I'll show you the cochlear ducts more in detail on another plaque. But that will give you an idea of the inner ear. So again, the inner ear is the semicircular canals, the vestibule, the cochlea, and then of course you need this very important nerve, the vestibulocochlear nerve. The vestibulocochlear nerve is of course the nerve that's going to carry the information back on your sense of equilibrium as well as your sense of hearing. So back to the brain, so very important. I think I covered all of the parts that we needed to cover here. I'm just making sure and double checking. Yep, it looks good. So those are the main parts of the ear that you need to know. And I'm going to go ahead and stop here and record another video of the eye for you.